Hello everyone. Today, we will learn about showing numbers on an 8x8 dot matrix display. An 8x8 dot matrix display is a very common display device consisting of 64 LEDs. By controlling the illumination of these lights, we can show various patterns and characters on the display. Today's lesson will focus on how to show numbers on the dot matrix display. I will start with the basic principles and gradually delve deeper until you master how to write codes to control the dot matrix display to show numbers or letters. It is hoped that through this lesson, you will be able to skillfully use 8x8 dot matrix displays, laying a solid foundation for future learning and projects. Next, we will mainly focus on the following topics. 1. What is a dot matrix? Previously, we used a method where one I/O port could only control one LED. What if we need to control more LEDs with fewer I/O ports? This led to the development of the dot matrix. An 8x8 dot matrix consists of 64 light-emitting diodes, each placed at the intersection of a row and a column line. When a specific row is set to high level, 1, and a specific column is set to low level, 0, the corresponding diode lights up. For example, to light up the first dot, set pin 1 to high level and pin A to low level, and the first dot will light up. 2. Dot matrix schematic. As shown in the figure, the structure of the dot matrix display is composed of LEDs arranged in an 8x8 pattern. The position of each LED determines its role in the display. By scanning rows and columns, we can light up the LEDs row by row or column by column to form the patterns or characters we desire. Understanding the dot matrix schematic is very important for subsequent programming and debugging. Next, we can open Proteus and use an LED component to simulate a dot matrix structure to better understand the principle of dot matrix displays. Proteus is a powerful circuit simulation tool that allows us to conduct various experiments and tests in a virtual environment. 2. Testing the dot matrix. In Proteus, select the matrix component and then choose an 8x8 dot matrix structure for testing. Note that the dot matrix in Proteus may not have clearly marked pins, so we need to test and verify them. First, connect a power source and try it out. If the dot matrix does not light up, it indicates that the polarity of the power connection might be incorrect. At this point, we need to adjust the polarity of the power connection and retest until we see the first LED in the dot matrix light up. For example, if figure 1 does not light up, it indicates that the bottom row is positive. By reversing the connections, we can see that the first LED has lit up, as shown in figure 2. By adjusting the power connection wires, we can discover that the upper half of the dot matrix controls the columns, while the lower half controls the rows. Based on these observations, draw a dot matrix schematic and mark its polarities, which will help in subsequent coding and debugging. Next, let's examine how images are displayed. First, it's crucial to understand the principle behind dot matrix, which is very important. The display principle of dot matrix is based on a scanning method, where only one column or row of LEDs lights up at any given moment. This approach effectively reduces the number of control lines required and, through rapid scanning, can achieve a visually flicker-free effect. The human eye does not perceive the flickering of LEDs under high-speed scanning, thereby allowing a stable display effect to be seen. Dot matrix scanning can be performed horizontally or vertically. We can choose the appropriate scanning method based on actual needs to display different graphics and characters. For example, to display the letter F, horizontal scanning can be used, displaying each row's content from top to bottom sequentially. Font extraction software is a very practical tool that can help us quickly generate codes for dot matrix displays. You can search online and download suitable font extraction software, then generate corresponding dot matrix data according to actual needs. During use, the generated code can be adjusted and optimized in the program to ensure that the display effect meets expectations. We will write a program to display the letter F and showcase its effect on the dot matrix display. The specific steps of programming include defining the row and column data of the dot matrix, converting it into corresponding control signals, and implementing the display through programming. The program and the display effect are shown below. Finally, let's write programs to display numbers. The key point about displaying numbers lies in the dot matrix code. Each number to be illuminated has a different hexadecimal value for each row. For example, the program to display the number 1 is written as follows. Finally, the display effect of the number 1 is obtained. You can explore how to derive the codes for 0 to 9 without using font extraction software. In this lesson, we have delved deeply into the principle of the 8x8 dot matrix display, including the composition of the dot matrix, scanning display methods, and the persistence of vision effect. Using Proteus, we have tested the polarity of the dot matrix, laying the foundation for subsequent programming. At the same time, we have mastered the use of font extraction software to quickly generate the code for displaying the character F on the dot matrix, learned how to write programs to show numbers on the 8x8 dot matrix display, and understood the differences in dot matrix encoding for different numbers. To better consolidate and deepen your understanding and mastery of the knowledge from this lesson, please complete the following exercises after class. See you in the next lesson.